This is easily the most programming that we've done to date in one lab project. And what we did in this lab project was added all of the safeties, not people safeties, but machine safeties. There's two types of protection that you put in your code. The most important one is a protection for people. But one that you definitely always need to consider is protection for the equipment itself. So you won't get in a situation where the operator pushes a button and damages the equipment. And one of the first things that we did was added logic that says if you're going up, you can't go down. If you're going down, you can't go up. In other words, you can't reverse the direction of the garage door when it's in motion. It can't be going down. You just hit up and then it goes up. Jerks to a stop and goes up. You have to stop it first. So we added the not down and the going up, and the not going up and the going down. Then we considered, how operators, if they get bored, sometimes they like to play with the buttons and see if they can cause interesting things to happen. So they may take and put their foot over in front of the light curtain, hold two buttons, and then bob their foot in and out of the light curtain just to entertain themselves. So we added logic, so if you push both buttons at the same time, up and down, and there can only be one reason for doing that. You cannot accidentally do that, push both buttons at the same time. You can push one and brush the other, but push both at the same time, no. So the only way that can happen is if you're fooling around, seeing if you can't either damage the equipment or make it do something odd. So we punish anybody who hits both up and down at the same time. And that's where we got the both push buttons pressed logic that we sealed in, and the only way that they can undo it, because if they do get both push buttons pressed, that stops everything, and it won't run again until you reset it by hitting the stop button, and then you can start it again. So we added the both push buttons pressed logic. However, we also added the photo eye, which is a human, or that could even be protection for stock that got unloaded from UPS or freight that's sitting in the opening of the door, or a human being standing there. If they're blocking the safety photo eye down near the bottom of the opening for the door, you can't run the door. Now we also put it in a way where if it's going up, it's not a problem. But if the motor's going down, then it's a problem, and it seals in. In this case, it's still called both push buttons pressed, even though it's both push buttons pressed or the safety photo eye got blocked when the motor was going down. So we added in some safeties, and that was the most important thing that we're going to do in this lab. Welcome back. Basic PLC Programming, Lab Project M6C, Garage Door Part 3. Approximate, page 137 in the second edition. Remember, the page numbers can shift as we add more content, remove content, but we're not going to go back and change the page numbers on these videos, but this gives you a rough idea where to go looking for this. If you're using the manual, you should already know and be kind of in sync with these lab project discussions and doing the actual projects in your manual. We're doing the garage door opener, kind of our elevation for the garage door. We have a segmented garage door that follows and tracks. I can't imagine anybody doing this course that doesn't recognize what they see. The only thing that throws people once in a while is they don't realize that the down limit switch, which is 1LS up at the top there, that it is not down at the bottom of the door. The door doesn't come down and hit it. A portion of the moving of the door hits it when the door is in the down position. And actually, both of these limit switches are, that's the down and that's the up, they're actually not even visible. They're probably inside the housing where the chain disappears to for your garage door opener. These are machine safeties. In other words, these primarily protect the garage door mechanism, because you could eliminate them and just hold down the down button, or just hit the down button, and when it gets down and hits the floor, you hit stop. And if you overload the motor a little bit, stress the mechanics, so what, right? And do the same thing on the up. So the limit switches are a good idea. The safeties we haven't added yet. That's what we're going to do in this lab project. We're going to add in the photo eye, the safety photo eye, that's down around ankle level or so, to detect if there's anything laying in the path of the garage door, including a person, a kid, a bicycle, a carton, your car. So that's a good thing. That's a safety photo eye. Now, there's another machine safety that we might consider, and that is the push buttons. If we leave our logic in a form that allows you to push both buttons simultaneously and put both forward and reverse on the motor, depending on the type of motor, that wouldn't be healthy for the motor. Now, if it's a three-phase reversing starter, that's another whole complexity. I think that in some cases would actually create a short circuit and pop a breaker or a fuse. And I thought I'd throw this in. Remember, the fuses and breakers protect the wiring, not the load. They protect the wiring going through your wall from overheating and starting a fire. They don't keep you from burning up the load, the motor or whatever the fuse, whatever circuit the fuse is in. All of these lab projects and discussions come from the first two manuals you see on this page, Part 1 and Part 2 of the fundamentals of PLCs using connected components, workbench, Micro 800 controllers. Okay, here we are with our previous project. Open back up and notice that I've changed the name of it. Look up at the top in the title panel, it says M6 Garage Door 03. So I changed the name of it. I went from 2 to 3. That way I can always back up to this, because this is how we left it at the end of 2. Now in 3 we're going to make some more edits. I've also opened up several displays here. Let's go down to, if you look, everything here is an input or an output. Once we start getting some other variables, then we'll have something else to look at. But for right now, this is all that we have to look at. So I've rearranged all this as we've been doing it. Remember, the output is here. I removed it from here because I don't want it popping up and blocking part of the view of the logic every time I do an edit. I've also pulled down the ladder view a little bit, because we only really need enough of the simulator showing down here, so when we click on it, it brings it up and we can turn inputs. Also, I'm not going to continue showing you the procedure to pull instructions into the rungs and certain functions that we've already gone over. I expect you to start doing those on your own. Now, if you're watching this video, it's because you've already finished this lab, or you're watching it to see what you're going to do in the next lab, and then you're going to watch it again when you're done with the lab. So I'm going to add some logic into these two rungs, specifically the safeties. And I'm also going to make a fat rung from two skinny rungs. In other words, both of these rungs use the stop push button as a condition. So why not make it one rung that uses a branch down to this part? So I'm going to do that while you watch. Now, there's several ways you can do it. I think the easiest and the simplest is just to drag down the branch. Probably the easiest way is just to drag these components inside of the branch here. Drag that over to there. This gets a little trickier. Now we're partway there. Now we need to bring this up to here. And then we need a branch around that. Let's try dragging the whole thing up here. Before we drag this in here, let's drag the motor down up to here, then drag this into here, then drag this to here, and we don't need this rung at all anymore. That was kind of a convoluted process. This is going to take some adjustment. If you're an RS Logix user, RS Logix 500, MicroStarter, RS Logix Studio 5000, you're going to find this editing branches more cumbersome than the other software. I'm assuming as different editions come out, it will become easier to use. So you just have to play with it. But this is what we wanted to end up with. So first of all, we wanted to, and by the way, I see that I want this up here and I want this down here just so it looks, see, up push button, down push button, motor up, motor down, the limit switches, and our seal-in contacts, output 0, output 1. To this, then, we're going to add several things. We want to eliminate them pushing both buttons simultaneously. So what we're going to do, we're going to go here, we'll bring down a true if off, and then I'm going to make that this input 2. So go up here, input 0, 2. Sometimes it's easier just to type it in there than to look for it. And this would be input 0, 1. Okay, so this logic says if you push the up push button and you're not pushing the down button, then you can seal in the thing to run the motor up. The other thing we wanted to add in as a additional safety is the state of the actual motors. Now you think the push buttons alone would eliminate it, but not necessarily. So let's drag in a couple more, true if off. Now we're going to have to spread out our logic a little bit to see it all, which means we're going to have to give up some of, and then what I want to do is say if this motor's not running, then you can run this one. So this would be OUT01. And I'm just typing them in. I'm not going looking for them, but we know that we can go here and type in O, and bang, we've got OUT, and here we want 0. In other words, if 0 is running, then you can't run 1 and vice versa. So here we have some safeties. Now these aren't human safeties. These are really still kind of machine safeties. Save, download. Let's check out our action here. So we bring up our simulator. We're in the run mode. And first we have to set one of these limit switches to continuity. So we'll say that we're down. Therefore this switch has to have continuity. 5. We also need the stop button to have continuity, so we turn on 0 and 5. Now we have the possibility of running it in the up direction. So if we send it in the up direction by double clicking on 1, turn it on, turn it back off, and now we're running up. And when we start running up, as soon as we do, the down limit switch is going to be untripped. In other words, the garage door is going to come off the down limit, and it's going to be on now. So now at this point, both these are true, but we're still going up until we hit input 5 and the motor stops. So now let's try doing up and down together to see what happens. So we're all the way up, so we can go down. So if I turn on input 1, nothing's going to happen because we're in the up position. We can't go up. So now I'm going to turn on input 2, and we can't go up or down because we are missing one of these two conditions. Now this rung to go true would have to have this be true, in other words not pushing the down button, and the up limit switch would have to have continuity in order to say that it's okay to go up. So this logic is all working. Now we can go down, so let's undo up and see now we're going down. So we'll turn off 2 because remember this is sealed in. Now let's try turning on the up, which we can't but we have to come off of this switch. So let's turn on 5, meaning that we're off of the switch because this would go true once the motor started going down. Okay, so now let's try input 1. This is all true, but because the motor is going down, this is false, and you can't energize the up portion of the motor control when you have the down portion going. Of course, if you hit stop, input 0, I'm going to double click, it stops the whole thing. Now, the reason it didn't stop, look at it for a minute. Watch this. I turn that off, the motors are off, then I let go of the stop button, it takes off again. Why did it take off again? Well, because the up push button is still being held down. That's the challenge with using the simulator and just using mouse clicks to control inputs, is sometimes you forget that the push button won't stay in that state. So now we hit the stop button, everything stops. We're not done with this yet. So let's save and disconnect. In the next part of this lab project, where it said get skinny, we added some additional logic for if the up push button is pushed and then not the down push button, then that little and or would be true. Or if the down is pushed and not the up. But if both are pushed, then it's not true. And basically that is a repeat of the logic that was already in there in series with each down push button right here. In other words, we took these two instructions, and created another and or out here, and it effectively is doing the same thing. And the reason I put that in there is because when you are trying to correct certain kinds of, or eliminate certain nuances, you tend to do things like that, and then you look at it and go, well, wait a minute, I already had that in there, so I'm going to take that back out. In the process of my thinking about this, that thought occurred to me. I put it in there and showed you in the lab project that it's just a repeat of what you already had in there, but it was the same thought, but just in a different spot. So we had you eliminate that. I'm not going to add that in and run it. Sufficient was what you saw in the lab project. Then we had you save and disconnect and add another rung. And that new rung has if up and down, you can also double click and it'll put it after wherever the focus is at. So the focus is here. If I double click there, see I can get more instructions to pop in down there. I tend to just drag them down. Now what we wanted input 2 and input 1 and input 2. So IN01, IN02, and then we wanted a output instruction or an OTE, a direct coil, and we wanted that to be a new bit called both push buttons pressed. So we type in both push buttons. An underscore doesn't hurt once in a while to make it more readable. We could leave out the underscore, except that you would had to have dropped the B down to lowercase to make it readable. This is a skill that you pick up after a while of making your tag names or your variables more readable from a casual glance. Variable selector. Now this is going to be a Boolean in the user global variables. We want it in here. So it's a Boolean, that's what we want. So we say OK. Now we have a bit that is true if both push buttons are pressed. And then we inserted that condition right here and took it out of here. So we eliminated this one, then we dragged down a true off. Type in B. Oh, a B alone brings it up. I typically type in the first two characters because a lot of times you have tags that have the same first character. And if there's a lot of them, one letter isn't going to bring up what you want. So I usually just type in 2 before I even look up. So there we've added this logic into this logic. Now notice our rung is getting a little fatter here. So I'm going to keep dragging it out until I don't have any jogs in my right power bar. And this is the logic that we had you then save and download. So this is our new logic here, and I had you operate this. So it's at rest right now. We can't have, well, it's at rest, but it's not up or down. So at this point, we can go up. So we double click on, and you see now we're running out of space here. So we can't see the logic and see the controller. So we're going to have to double click on one. It's going up, and then we can stop it. We can go down and stop it. But let's say we push both buttons. Okay, both push buttons are pressed. This is false. Both push buttons are pressed. This is false. And so now we can't run either. Now with both push buttons pressed, I'm going to drag down this a little bit. We're going to lose our outputs down at the bottom, but we don't have any on right now. But we can see them over here. We can see our outputs right here. And then I had you release one of the buttons. It really doesn't matter which one. We'll release the down so it goes up. Or we could have released the up so it goes down. And if we have them both pushed, it's disabled. And the question was, what do you think will happen when you are no longer pressing both buttons? Well, it depends on which one you release first. Even if you could release them simultaneously, one of them is going to be red before the other. So if you released the up push button before the down push button, then it would go down. If you release the down before you release the up, then it would go up. So the scan order doesn't really come into play. But we don't want it. We don't want this. We don't want any unexpected motion. We're going to change the code. I'll stop this. Double click on 00. That stops it. So we had you exercise your logic and then save and disconnect to make some more edits. I'm going to turn off, well, both buttons are turned off, we're good. So save and disconnect. Okay, this is the logic the way that we left it. We're going to make some edits and come right back. First thing we want to do is if both push buttons get pressed, and how you would do that accidentally, I'm not sure. It's possible. Either way, we don't want the operator doing that. And if they do it just for fun, we want to give them something to deal with for all of their efforts. So we're going to grab a branch around, and then we're going to drag. So both push buttons pressed, turn on, both push buttons pressed. Then we'll come down here, drag in a seal-in contact, and then type in B for both. There it is. Okay, now we have both push buttons pressed, sealed in. So if this happens, this is going to come on and it's going to stay on and keep them from starting again. So now you're looking at this, and if they release the push buttons, they're still not going to get started again because this is sealed in now. So even though you release one or both of these push buttons, that doesn't make the run go false. This stays on and this is false, and you cannot start the garage doors again. So now we add in the stop push button as a reset. So we drag down a true if on, and then we can type in IN00, IN00. Now, if they push the stop push button, because remember, this is a normally closed, so this would be true. So if both of these are true, in other words, they push these two buttons, let's just download it and test it. That's what I had you do in the manual. Save it and download. Okay, here we are online and at rest. Now we're not up or down. So let's make it down. Let's just say the thing's down. So I'm going to go to my controller and turn off that switch. Okay, we had these both true, meaning that neither one was tripped. So it was somewhere in between. So I firmly put it in the up position. Okay. So now we're going to go to the up position. We're going to double click on 1. Now you see it's going up. Now we double click on 2, except that if I double click on 2 now, nothing's going to happen because they're not both pushed. That's another situation that we might want to deal with, is we don't want the door doing something when it gets down. So for right now, what I'm going to do is also turn on input 1, so they're both pressed, because that's what we were demonstrating. Keep in mind that other problem, if you are holding the down push button while it's on its way up, what happens when it gets up? So that's another situation for another day. But you can see what happened here. Both push buttons are pressed. So let's release, and it doesn't matter which order we do it in. Okay, we turn them both off. However, this is still false because that's still on. But if we do the stop push button, double click it, that clears this, and now we're ready to run again, and we can continue going up. That's the extent of that logic right there. And the question, there was a couple questions in there. Look at this logic. Will pressing both buttons simultaneously set the memory location of both PB pressed to on? Yes. If you release one or both buttons, will the run go false and set the bit to off? No, it's sealed in. And then the next question down there was, both buttons pressed, motor not energized. What do you think will happen when you release either or both buttons? Nothing, because we've added in this condition right here. So if you release one of these or both, you still have both. You still have this bit on. This is be false, and you can't run it up or down. You must reset it with the stop push button. That's good use of your available input field devices. That stop push button can be used for more than just stopping. But keep in mind that if you use it and it's running, it's going to stop. But if it's not running, then you can use that stop button for anything that you want, simply because it's not going to interrupt anything. Now you can't hold it down and then try to start it, but you get my drift. Then we had you release either or both buttons to see if you were correct in your analysis. Both push buttons released, motor not energized. Okay, they're both released, motor not energized. Can you energize up or down from the current state of this logic? Well, this is what we had, okay? In the manual, I gave you this set of conditions. So the up limit switch is not tripped and the down limit switch is not tripped. So it's neither up nor down. That's what it shows in the manual. And it shows these are both true. You're not going up, you're not going down. But this is on. I'm just going to go ahead and toggle this on. This is an internal bit so I can get away with that. Okay, so see, this is back on. This matches step 11 on page 141 or thereabouts. So it asks you if you could energize up or down from the current state of this logic. No. Why? Both push buttons pressed, still sealed in. So even though these aren't being held down right now, because this is sealed in, you can't go anywhere. What does the operator have to do to regain control of the motor? Stop push button. Press and release the stop push button. So we go back to our controller. This would be like pushing the button and releasing it. Okay, that cleared the both push buttons pressed. Would you say that you have total control over the motor, its direction, and have eliminated unexpected motion and have to make an expected interaction with the operator interface buttons to reset the system? Yes. Then we had you save and disconnect. We want to add the safety photo eye. We're going to branch around, both push buttons pressed. We're going to add in a true if off for the photo eye, which is input 3. And we're also going to add in the condition that it has to be running in the down direction, which is output 1. Now it does make a difference what order you do this in. If you try to branch all the way around and then try to move the stop push button out of this branch system, you're going to run into some trouble. Again, I will mention that doing the branches with CCW is a little bit more cumbersome than with RS Logics. It's not quite there yet. Now this is mid 2020, so that can change with version 13. Save and download. Let's go up. Okay, looks like we can go up or down. Okay, we can go up or down, so let's go up. We're on our way up, and then we trip photo I3. Still going up. Untrip photo I3. And now let's stop and go down. Double click on 0, we're stopped. Now input 2, double click, we're going down. Now let's trip photo I3. See what happens? It stops going down. We untrip photo I3. We're no longer going down, so this is no longer a true branch. If we reset this with the stop push button, and we're ready to go again. Okay, we can go up or down because neither limit switch is tripped. We don't have a fault here. And by the way, I will eventually change both push buttons pressed to safeties because it includes more than just both push buttons pressed. But in the manual, I left it like this. That's how I'm going to leave it here. So let's go up. So we click on input 1 twice. We're going up. We'll trip photo I3 by clicking on it twice. Does not affect going up. Now let's stop it and go down. So we're stopped right now. Let's do input 2 on off. We can go up or down because neither limit switch is tripped. So let's go up. Click on input 1 and back off. We don't want to leave it held. Now if we trip the photo eye, we double click on 3 here. That's the same as something passing through it. Nothing happens. Okay, we're going up. So let's stop. Double click on 0. Everything stopped. Now let's go down by double click on input 2. We're going down. Now double click on 3. See, it stopped. Double click on 0 and it's reset, and you can start again, going up or down. Now, how do you know it's not up and not down other than the limit switches here? Well, the person that's operating the garage door, if they try to go up and it's already up, it isn't going to go anywhere. So it won't take them long to figure out they can't go any more up. And if it's down, that's easier to see than up. It's easier to see that it's down than to see that it's up, because... So that's it for this project. We're going to save. Well, we answered all the questions in the manual, so you could fill in the blanks or check your blanks that you filled in. And we had the garage door opening and closing fairly good in a kind of a basic mode, but we're not done yet. We still have more to add. So let's tidy up this lecture discussion on this lab and get on with the next one.